Good evening, dear students. Let us continue with the problems on transformer. So, this problem states that a 50 kVA 400/200 volt single phase transformer has an efficiency of 98% at full load and zero point 0.8 power factor, while its efficiency is 96.9% at 25% full load and unity power factor. Determine the iron loss and the full load copper loss, and also voltage regulation if the voltage on full load is 195 volts. Now let us write first what is the given in the problem. Rating of the transformer is given, that is 50 kVA, and then they are given you primary voltage of 400 and secondary voltage 200 of a single phase transformer. Full load efficiency at zero point 0.8 power factor is also given as 98%. Now let us recall the formula for full load efficiency. It is VA into cos phi divided by VA into cos phi plus WI plus WCU, that is iron loss plus copper loss. VA is nothing but this rating of the transformer. Cos phi is the power factor of the transformer which is given. So now let us substitute the same thing over here. So let me make you one more thing clear here. If you are using kVA over here, that is kVA into cos phi, and here also kVA into cos phi, then you need to take iron loss and copper loss values which you get finally in kilowatts. Suppose if you are taking VA, you need not multiply with the kilowatts over here. You can take the direct rating. So now substituting these values, we get 0.98. That is removing the percentage over here. That is equal to VA is 50 kVA. So 50 into 10 to the power of 3, that is 5000 into power factor cos phi is 0 0.8 divided by, again write down the same thing, plus iron loss plus copper loss. So we get the equation 1 by simplifying the above values. Again, they have given you one more condition at 25% full load and unity power factor. The efficiency given is 96.9%. So remove this percentage and substitute over here, that is 0.969. So now you again substitute the values given in the formula over here. That is X value is known. If they give you 25% full load means the value of X is 0.25. That is 25 divided by 100 X value into VA rating into power factor. Power factor is unity, means cos phi value is 1. So I have just not written anything over here. Just I have multiplied by X. Again divided by X value into VA value, that is the rating of the transformer, plus iron loss, plus again when you're writing the copper loss equation, you need to multiply by the X square factor, that is 0.25 square, that is 0.25 into 0.25. So we get one more equation, Wi plus 0.0625 WCU as equal to 399.896. This is equation number 2. Now solving equation 1 and 2, we get the values of iron loss and copper loss. See, since we have taken in VA value, we have just written the iron loss and copper loss in terms of watts, not in kilowatts. If we take here in terms of kVA, then you need to represent Wi and WCU in kilowatts. So we got the value. Finally, iron loss is this value and copper loss is this value. So one more parameter we need to find out, that is voltage regulation. So for voltage regulation is defined as the ratio of no load voltage to full load voltage divided by full load voltage, that is voltage on full load. So no load voltage is nothing but the secondary voltage, because we are connecting the load at the secondary of the transformer. So 200 minus 195 divided by 195, we get 2.564%. So let us move on to the next problem. So in this problem, the maximum efficiency at full load and unity power factor of a single phase 25 kVA 500/1000 volts 50 hertz transformer is 98%. So full load efficiency is given. Determine its efficiency at 75% load, 0.9 power factor, 50% load, 0.8 power factor, 25% load, 0.6 power factor. So we need to find out the efficiency for these three conditions. So let us first list what are the parameters given. Rating of the transformer is given. The maximum efficiency at full load and unity power factor is given. Unity power factor means cos phi value is 1. So substituting in the equation, that is efficiency is equal to VA divided by VA plus iron loss plus copper loss. Because here at full load X value is also 1 and here the power factor is also 1. So we need to write only VA value, that is rating of the transformer. So from this I get, and also one more thing, at maximum efficiency what is the condition? Iron loss is equal to copper loss. So substituting that, we can write this 25,000 divided by 25,000 plus 2 times Wi or 2 times WCU. So we can solve for one value, so which is again equal to another value. So we get iron loss and copper loss as 255.1 watts. Now we know what is iron loss, copper loss. We need to find out the efficiency for those three conditions. So the first condition is efficiency at 75% load, 0.9 power factor. So X value here is 0.75. This is VA rating again into, this is the value of cos phi, that is power factor. So X VA cos phi divided by X VA cos phi plus iron loss plus copper loss. See again, when you are taking copper loss, be careful to multiply with a factor of x square. Here x is 0.75. So we get this value of efficiency. Next, efficiency at 50% load, 0.8 power factor. The same way, only thing is here x value is 0.5 and cos phi value is 0.8. So use the same formula. Don't forget to multiply copper loss with 0.5 square. We get the efficiency. So for the third case, what is the value of x? It is 0.25. And what is the value of power factor? It is 0.6. So substituting the values, we get the value of efficiency. So move on to the next problem. A transformer is rated at 100 kVA. At full load, its copper loss is 1200 watts and iron loss is 960 watts. Calculate efficiency at full load unity power factor and at half full load 0.8 power factor. The load kVA at which the maximum efficiency will occur and the maximum efficiency at 0.85 power factor. Now look at the solutions. Write down the given parameters. Transformer rating is given 100 kVA. Full load copper loss is given. So I'm just writing in terms of kilowatts as 1.2 kilowatts. So iron loss is given again 960 watts. In terms of kilowatts it is 0.96 kilowatts. So let us find the first parameter, efficiency at full load. Full load means X is 1. And here again unity power factor. So the value of cos phi is 1. So substituting over here. So observe in this. So previously we took as VA, right? VA divided by VA plus iron loss plus copper loss. Here you can take it as kVA also. But I told you, you need to remember to represent the iron loss and copper loss also in kilowatts. Suppose if you are taking it as kVA over here. So here it is 100 kVA, 100 by 100 plus, see 0.96 kilowatts. That's why 0.96 plus 1.2, it's again kilowatts. So 1.2. So now all the parameters are in kilo. So that becomes a correct solution. If you are writing here in VA and here in kilowatts, it becomes wrong. Or here if you write it in VA and here if you write in kilowatts also, it becomes wrong. So take care that all the units should be uniform. So with this we get the efficiency value as 0.9788. So in terms of percentage, 97.88%. Next we need to find out efficiency at half full load. And power factor is 0.8. So the X value over here is 0.5. Here again kVA rating is taken. Okay, cos phi is 0.8. So the same thing over here, plus iron loss, again in kilowatts it is taken, plus 0.5 square it is, okay, it is square actually, into 1.2. So 0.5 square times copper loss. So we get the value as 0.9694 or 96.94%. The load kVA at which the maximum efficiency will occur is, what is the formula for load kVA? It is kVA rating into square root of iron loss by copper loss. So we get 89.44 kVA, because here we have taken in terms of kVA. So your output kVA or load kVA also will be 89.44 kVA. Next, find out what is the maximum efficiency at 0.85 power factor. So how do you find? So take the kVA rating, multiply by 0.85, again divided by kVA into power factor. What is the value of X at maximum efficiency? It is 1. So that is why we have not considered over here. So plus again iron loss plus copper loss. So iron loss is equal to copper loss in case of maximum efficiency. So we get the efficiency value as 0.9753 or 97.53%. So in the next problem given over here, it is 600 kVA single phase transformer has an efficiency of 92%, both at full load and half full load, unity power factor. So determine efficiency at 75% full load, 0.9 power factor. So let us write the given parameters. So transformer rating is given, efficiency at full load unity power factor is given, and efficiency at half full load unity power factor is given. So let us substitute these in the values over here. So efficiency is equal to kVA into cos phi divided by kVA into cos phi plus iron loss plus copper loss. Since it is full load efficiency, we are not considered X value over here. So from this, I get an equation by substituting over here as iron loss plus copper loss equal to this much. See, I have taken in kilowatts because here I have used kVA. Is it clear? Okay. So efficiency at half full load. So I'm multiplying by 0.5. Here also I'm multiplying by 0.5. So again, iron loss plus. So here also I should multiply by 0.5 square over here. Okay, I'm not indicated. Excuse me. So see in the formula I have included. So efficiency is 0.92 equal to, so this again 600 into 0.5. Here again 600 into 0.5. What is the power factor? It is unity. So we are not written over here. Plus iron loss plus 0.5 square times copper loss. Okay. So now we get the expression as iron loss plus 0.5 square copper loss is equal to 26.087 kilowatts. Again see kilowatts because we are used kVA over here. Fine. So this is equation number 2. So solving equation 1 and 2, we get iron loss and copper loss values. So now with this iron loss and copper loss value, we can find out the efficiency at 75% full load and 0.9 power factor. So which is nothing but again kVA into, this is X value. Okay, this is power factor. Again, you substitute the same thing divided by plus iron loss. Okay, then this is copper loss. Copper loss should be multiplied by X factor. That is square of the X factor. So we get efficiency as 91.638%. Okay. So with this, we come to an end of this online lecture on transformer, that is numericals. Thank you.